Alright, I'm sure you guys had some time to work on it. Some of you probably realized, hey, let's just drop an altitude in there. In other words, cut this triangle. It's equilateral. So if you cut it down the middle, you now have two special triangles, which makes this problem much easier. Makes it look a lot like something you've already done before. Sorry, that was cut off there. It's an equilateral triangle. I know I said it in the last one, but it was cut off. So if this whole thing was 8, because it's 8 comma 0, that means this is 4. And you know this is 8. You could certainly use Pythagorean theorem to get this. This vertical distance, which the vertical distance here is actually b. A is probably obvious. A is just 4. A is half of that distance on this. We've got 4 comma whatever this vertical distance is. If you know your ratios, this would be a 1 to rad 3 to 2 ratio. Use Pythagorean theorem, you can solve it as well. You know, 4 squared plus b squared equals 8 squared. And you can solve it that way. Obviously the ratios make it a little easier. You know you're going to have a rad 3 in there. This is 4. This would have to be 4 rad 3. Is the quicker way to get there. Whoops. So A, simply 4. The vertical distance here is 4 rad 3. You could get those coordinates in terms of the 8 or in terms of other letters. Similar idea with a rhombus. And we've talked a little bit about what a rhombus is. It's not just a parallelogram. It's a specific type of parallelogram where all 4 sides are the same. So 4 congruent sides. When you draw this, try to draw this side congruent to this side and this one. It's a square that essentially doesn't have to have right angles. You know, smushed over, tilted over. And I'm going to give you some numbers on this, and you're going to try to find the values of A and B again. So this first corner is 13 comma 0, and that top left is 5 comma A. And the top right is B comma A, which makes sense if they have the same y coordinate, because this is a horizontal line. So, see if you can find A and B using the fact that a quadrilateral has 4 congruent sides when we call it a rhombus. And this is, you know, I set my clock here. If I was in class, I would let you think about this for 2 or 3 minutes, discuss it, hopefully come up with something. It's a little tricky. It is an application of Pythagorean theorem again. So if you're still stuck, and you have paused it, hopefully you paused it, tried it for a couple minutes, ask yourself this question: how long is this side? Oh, 13. How long is this side? 13. Which means B is a pretty easy value to get. This distance, of course, we know is 5, because that's its x-coordinate. 5 plus this 13 gives you 18 for that value. So B is pretty easy. That's the horizontal distance all the way to here. Or you can go 13 plus this would be 5 down here if I went, you know, directly underneath that point. This would be 18 comma A to get me there. The trickier one is to find the vertical distance here. And of course, if you recognize these side lengths are also 13, you can see you can apply Pythagorean theorem here. So if I draw that altitude in here, you know this is 13, you know that's 5. This is your mystery value, and you might realize it's a special triangle, Pythagorean triple. And you end up with A is 12. Oops. So those are the values I'm hoping you could get. Hopefully they make sense on there. Tricky questions, but you got a couple like that on the homework. Good luck. We'll see you on Friday, hopefully. Give this worksheet a try in class. Hopefully Sub will give it to you. Enjoy.